Hello and welcome to session on Smart Table Design, Learning Objectives. In this session, we will learn the followings. What exactly atomicity is, different keys we will use in our SQL table design, what is normalization, how one column of table has dependency upon another column, and finally, we'll talk about different type of normal forms. In our initial chapters, we have helped Jeff and Craig to design their table and query the data from it. While using the database, it filled with a huge amount of data, and in latter phase, they started facing issues in retrieving their data and wishing they would have designed their table in a way that made their statement simpler. Finally, after an exercise, they made it possible. To see how other sailors are doing, Jeff made two booksellers, Mike and Billy, who were also using database to maintain their data. Jeff asked for their table structure. So if you see Mike's customer table, he has kept city and state in same column, address, and on the other hand, if you see Billy's table, he has created a new column for city. This is the exact situation which Jeff wanted to understand and see how other people are doing it. So Jeff asked Mike why he has kept both city and state in same column. And Mike answered that in most of the cases he communicates with emails, so he does not use address much. That's why he created a single column for address. Alright. Now Jeff asked Mike to give the list of all customers from California from his table. And look what Mike has written. Select star from customers where address like California. Now Jeff reached to Billy's store and asked him the same question. And what Billy told him is he often queries data using state column. So for his advertisement purpose, he kept state as a separate column. So how would Billy find customers from California? And Billy has written a straightforward query. Select star from customers where state equal to California. So what do you say? Whose table is better? As per me, both tables are correct, as both tables have designed for their own purpose. So if we see the situation for both Mike and Billy, the data is atomic enough for them. So is using like is risky? No, there is nothing wrong in using like, but it is difficult for huge amount of data, and it may be a risk that you get a result that you do not need. Alright, you are not able to understand what I am trying to say. Let's take two situations. For a pizza delivery boy, he just needs the street number and complete address in a single column. So for him, this order table is atomic enough. He can just search for his orders and get his result. He just need to directly write select address from our orders where order number equal to 305, and he would get his address. But on the other hand, for a real estate agent, he might want to have separate column for house number because he want to write select property type from properties where street is 100 Main Street. So for both of the situation, the table is atomic enough for people who are using it. Alright, let's talk about the rules of atomicity. So rule 1 says a column should not have several values of same data type. Consider this table food details. What happens when you try to search item using cucumber or onion? Will you be able to search? It seems like impossible, right? So to accept rule 1, we need to create two separate tables for each ingredients. Now what we have done is we have segregated the ingredients column into ingredient 1, 2 and 3. So now as per rule 1, our table is atomic enough. Now let's talk about second rule of atomicity. Second rule says a table should not have several columns of same type of data. If we again have a look on our food details table, we have multiple columns of ingredients and all these columns are having same type of data: tomato, cucumber, onion. So currently our table is set with rule 1 but violating rule 2. So it is still not atomic yet. So let's take a final call on our table and set it to follow rule 2. To make atomic, what we have done is we have divided the table into two pieces. One for food item, another for ingredients. Now if we analyze both tables with atomicity rule, then these tables are following both rules of atomicity. Wait a second, why should I make my table atomic? Exactly, this is an obvious question which comes in our mind. So atomicity will help us in design a smart table where we can search our result easily, and that is where the concept of normalization comes in picture. Normlization. So normalization is a process of efficiently organized data in a database. What does it means to be a normal table? So the answer is we have a set of rules we need to consider while designing the tables. Next question, why should I design a normal table? Normal table won't be duplicate data. And my answer is normal table won't have duplicate data that will reduce the size of table, and when you have less data to search in a particular table, your query would be faster. Let's talk about first normal form. A table is in first normal form if it follows these two rules. Rule 1 says each row of data must contain atomic values that we already have discussed. And rule 2 says each row of data must have an unique identifier. In later phase of chapter, we'll start calling it primary key. But before we move further, let's make our concept clear about what exactly this primary key is. So a primary key is used to uniquely identify the records in a table. So to make column primary key, we need to follow a set of rules. So our first rule says primary key cannot be null. If you set a primary key null, it cannot be unique, as other records can also be null. Primary key should be unique. It should not be duplicate. A primary key must be assigned a value while creating a table. And a primary key value cannot be changed. So we know the rules of primary key. We'll apply these rules in later phase of our. If you see both tables we have created, these both tables are following the rule number 1 of first normal form, which says table should be atomic. Now if we remember the second rule of first normal form, it says table should have a primary key. So while making the table atomic, we already have assigned a primary key to food table. If you can see, we have FID, which is a primary key, and we can search the records uniquely using FID. But on the other hand, if we see the ingredients table, it still does not have a primary key. If we try to search using FID, there are multiple records will be populating for a single key. So to mitigate this issue, we have combined two columns of a table to search the data uniquely. So it becomes a 2-column primary key. What the heck? 2-column primary key? Can I combine multiple columns to create a primary key? Don't we discuss primary key should be a single column? I believe you also have same question in your mind. Yes, we can make a unique key which combines 2 columns to identify the records, and we call it composite key. So what exactly this composite key is? So composite key is a primary key which comprises of multiple columns to identify records uniquely. So if we combine two columns of a table to search the record uniquely, we call it composite key. Consider this table. If we individually see FID or ingredient column values, they are repeating. If you can see, cucumber value, tomato are repeated. FID values F01 is repeated multiple times. So if you try to search using F01, it will give you multiple records. Same in case of ingredients. So what we can do is we can combine both FID and ingredients column to make it unique. Now both the columns combinedly able to search a record. So finally we know what is primary key and what exactly composite key is. And we already have idea of the rules of first normal form. So it's a world of relation, right? And we are talking about relational database system. So in next slide, we are going to talk about some dependency which one column have on other columns of the same table. Let's analyze the dependency of column in this table. So let's say if we change the value of book column, it will directly impact few other columns of tables like category. If I change the book name The Alchemist, it will change the category of book. Even it will change the category of authors and copyright. And once author changes, the phone number will also be changed. It means column author, category, copyright are dependent on books column. In SQL, we call it functional dependency. So by the word functionally dependent, what I mean is if you change book, category, author and copyright will automatically change. In this table, we are treating books and customers as composite key. So book and customer, both column would be known as composite key columns, and rest of the columns would be known as non-key columns. Now if we see author column, it is dependent on one of the column of composite key, that is books, but it is not dependent on second composite key column, which is customers. Same can be applied for copyright column. So author, which is non-key column, is only dependent on one of the column of composite key, which is books. This is what partial dependency. So partial functional dependency means that a non-key column is dependent on some but not all the composite key columns of a table. Let's talk about transitive functional dependency. Consider this table. We are treating book as a primary key and rest of the columns would be known as non-key columns. Let's say if we change book, category and author would be changed, and once author is changed, phone number would automatically change, which is a fine behavior. Now let's try to see the impact of changes in a non-key column. If you change category, author may not be changed, as he would have been written a book of different category. But if we change author, phone number would automatically change. So what transitive dependency says is, if changes in a non-key column impacts another non-key column, then we are in the situation of transitive functional dependency. In our case, table is having transitive dependency because changes in a non-key column, which is author, is impacting other non-key column, which is phone number. Wait a second, why are we talking about these dependencies? What do they have to do with our normal forms? So we are talking about these dependency as these are required to make the column normal. Let's check our rules of second normal form. First rule says your table should be in first normal form. That we already know how to make first normal form. And the second rule says your table should not have any partial functional dependency. As we have discussed earlier, partial functional dependency means that a non-key column is dependent on some but not all the columns of composite key. So if we recall our table, many of the columns like author, category and copyright are partial functional dependent on books column. So the table is not in second normal form. We need to remove this dependency, and for that we have to further divide this table. So what we have done is we have removed partial functional dependency. We have divided the table into two parts and assigned a primary key in both tables. So we have created a book info and customers info table. Now the question is, we have divided the table into two parts. So how will we write queries to get the combined data? This is where a new key enters in our directory, foreign key. So if you see book ID column in customers info table, book ID is working as a foreign key in customers info. Alright, we have already covered primary and composite key. Now what the heck this foreign key is? So foreign key is a column in table that reference a primary key of another table. Foreign key can have different names than the primary key of other table. You can set the value of foreign key as null. Even primary key value cannot be null. And unlike primary key, foreign key do not have to be unique, and generally they are not. We don't keep it unique. So now we understand that foreign key let us connect two tables. But what is the use of foreign key when it is null? Can't I restrict it to be not null? Yes, of course you can restrict it. So for that, SQL provide a feature called constraints. We will talk about these constraints in a separate chapter we have. But before that, let's talk about third normal form. So if you want your table in third normal form, then your table need to be follow the below two rules. First rule says your table should be in second normal form, which we already have created. And second rule says your table should not have any transitive dependency. And transitive dependency is when a non-key column is dependent or related to another non-key column of the table. Let's see. We have courses table with us. Let's check what would happen when we do some changes in the value of non-key columns, which are instructors, courses or phone number. So if we change course name, it will neither impact instructor nor phone number, because one instructor can teach multiple courses. And if we change instructor's phone number, it will neither impact course nor instructor, because one instructor can have multiple numbers. But if we change instructor, phone number would automatically change. So instructor is a non-key column, and when we are changing the value of non-key column, it is impacting another non-key column. And we remember the rule of transitive dependency. So as per transitive dependency rule, this table is in the situation of transitive dependency. So to remove transitive dependency, we have created two separate tables for instructors and course. Now both the tables do not have any transitive dependency. So finally, we have reached the rule of third normal form. So with that, we have hopefully completed the concept behind normalization.